Hi everyone, let's talk about functions. We've already seen a lot of the built-in functions in Python that we can use, but it is also really easy to write your own function, and this is really important, especially as you start to build larger programs. So the keyword we need to create our own function is the def keyword. We follow that up with the function name and two parentheses, then a colon. Below that, indented with one tab, we have the code that is actually executed when we call the function. For now, we'll just print some stupid string out here. When we now hit enter and enter again, we define this function, great function, and this one is now available like any other name in our namespace. And we can look at that name and it will tell us that this is indeed a function, and this tells us where this function lives. Now, to actually call this function, we need to take the name and follow it up with two parentheses. And then the function will do what we set out to do. It just prints exactly this string. Now, one problem with that function is that it doesn't take any input. But we usually want functions to be able to take input and then process it in a certain way. To allow our function to take input, we put in the parentheses what we call parameters. So a and b, again followed by a colon, and then we print for now a times b. Now when we define that function, we have now a and b as parameters, and those parameters are not optional. If we try to call this function without them, it will give us an error and tell us that these two arguments, a and b, are missing. So it is now required for us to put something as input for a and b. And then it works. Now, if you don't want to call a function every time with inputs, you can set defaults for these parameters. You can set a equals 1 and b equals 1. Now we'll simply print both of them, and also we'll print their product. Now when we call this function without specifying a or b, a will simply be 1 and b will be 1, as we can see here, because these are the defaults. And now there are several different options, there are several different ways we can call this function. There are a lot of possibilities now. For example, we can pass a as a positional argument here and leave b out. And this will mean that a is 5 and b is 1. So b will default. We can also, of course, specify both of them. Then we have the option of using what is called a keyword argument. These arguments, these parameters, are passed by position. The positional arrangement is that a is the first parameter and b is the second parameter. That's why 5 will be a and 4 will be b. But we can also use keywords. So we can explicitly define b to equal 4. But we can a, because it's still positional here, a is the first one, will still be 5. We can also make both of them keyword arguments, like this. One thing we cannot do is have a keyword argument before a positional argument. Any keyword argument has to be after the a positional argument. So this will give us an error. Sometimes you want your function to be able to handle differing amounts of parameters. So for that, we can use this construction here with asterisk args. This simply introduces the possibility of having as many arguments as you want. You can pass as many parameters to this function as you want after a and b, and they will be collected in this arg's name, which will be a tuple. So now we can again call the function without anything, and then we see a defaults to 1, b defaults to 1, and args is simply an empty tuple. If we call the function with defining a and b, we get a is 5, b is 2, And the tuple is again empty because we did not specify any additional parameters. Now, we can also put as many arguments in here as we want. And then these additional arguments will populate this tuple here. And this tuple in this function will be accessible to you through the arg's name. Now, these additional parameters, they are all positional. You cannot have additional keywords here. This will give you an error because args can only catch non-keyword arguments. If you want to be able to also have keyword arguments, you need an additional construction. You need the double asterisk with KW args. KW simply stands for keyword arguments. Now we also print those. And now we are able to provide keyword arguments. And those keyword arguments that are additional will all be collected in a... And those keyword arguments will all be collected in a dictionary, where the key is the name and the value is exactly the value. And now we are also able to combine additional positional arguments with keyword arguments like this. Now 5 is A, 2 is B, 10 and 20 will populate the args tuple, and test, the additional keyword argument, will populate this dictionary. Now we skipped one important thing about functions, and that is the fact that functions always return something. And that means that whenever we assign a name to the result of a function, we get a value back, we get an object back. And we didn't define any return statement here, so this one will simply be none. By default, if there's no return statement, the function returns none. And this is a fine way to write a function. Functions can do things by what we call side effects. A function just does something to certain objects, or it prints something to the console. But in most cases, we want to get something back from our function, like the result of a calculation, for example. And for that, we need to use the return statement. The return statement ends the function. So whenever the return statement is invoked, the function ends. So return finishes the function and returns exactly what is behind it. So here we return the result of the multiplication a times b. We can test this now. And now func result will not be none, but it will be 10. With a when we pass different arguments, it's now 15. So this was a very quick introduction to functions, and probably too quick looking at their importance, because most of the things you will encounter are encapsulated in functions. When you reuse other people's code, you're usually reusing functions. And because functions are so important, in the next video we will look at the issue of scope. So functions are self-contained and we can pass names to that function. The problem with that is that then what kind of name is and because functions are so important, in the next video we will look at the concept of scope. A function is self-contained and it has its own concept that is called scope. And scope is important to figure out what kind of name what kind of object a name actually refers to. Because we can have a name outside of the function and the same name within the function. Or we can call a name inside a function that is not defined in the function at all, but it's outside of the function. And this is a concept called scope, and it's important to understand how names are resolved within functions. This is what we'll do next, and this concept of scope also relates to namespaces. And this will And because functions are so important, in the next video we will go a little bit into detail on them, and we will specifically talk about the concept of scope. See you then.